Good afternoon. It's my second time in Atlanta. It was 5 years ago. So this is Miguel Duran from Girona, northern Spain, close to France. Okay, here in J for J in J. What does that mean? Okay, maybe I'm one of those guys that pollute, contaminate, do nasty things. Maybe I'm a chemist. Oh, yes. These are gallium symbols, gathering from Gardner in Georgia. But for me, GA, that's gallium. Oh, apologies, I'm sorry. But this is kind of a chemist. I must say that in my hometown in Girona, near Barcelona, we have the reputedly best restaurant in the world. But look, a restaurant is just a place where you have a kitchen. What's a kitchen? At every home, every nice chemical lab. Everyone has a chemical lab at home with the best and worst reactants. I'm going to talk to you about the chemical table of the elements. So this is a very, very old one: wind, fire, water, and earth. So rows are humidity, non-humidity, and columns, or the contrary, are cold and hot. But this is the new, real periodic table of the elements. This is almost 120. Oh, like it's up to date. This is our skyline with our cathedral, churches, and everything, like in Atlanta, so no problem. So, by the way, there is a molecule called Gardner. Oh, this is a nice plant. This is an alkaloid. Did you know about that? I just found it in our Web of Science. So, nice molecule. Okay, Gardner talked several times about the periodic table of the elements. That's the cornerstone of chemistry. Where did he talk? In one of the books about how extraterrestrial people would think about how an apple tastes or how a helium atom is. It's much easier to figure out when we communicate with extraterrestrials about how an atom is. Mathematics is there. Much difficult how an apple tastes. And furthermore, talking about combinatorial, he talked about the Pauli exclusion principle. So, G4G1, or should be G4GA, like someone said this morning. Or maybe gallium, beryllium, gallium, sodium. I was really very surprised, positively surprised, to see that here we have symbols, small cheating by the way, okay? But have all kinds of atomic symbols. So congratulations to the organizer. And also, JJJJ, also gathering for Duran in Georgia. Some curiosities. Zip code in Atlanta in Georgia is 30. Gallium is 31. Oh, near miss, almost, okay? Pure chemical elements, not combinations of substances, are really present in magic. Which is the most important one? Would you get it like? Gallium, okay? Because you get a gallium spoon at room temperature, it's just strong. But if you take it with your hands, it will bend automatically, because melting point is about 25, 30 degrees. Great, this is magic. You can do all kinds of things indeed with phosphorus, iodine, sulfur, mercurium, almost all the periodic table of the elements. They are present in magic. What about the beauty of bismuth crystals? I cannot talk about alloys because they are not pure elements, but they come, for instance, materials with memory that are really used in magic. So, why do I talk about this? Because 3 years ago it was the International Year of Chemistry, and this year is the International Year of Crystallography. And that reminds me about quasi crystals, pendle styles, art, Islamic art, golden ratio, and all kinds of modified geometric tricks by Duran. So, why are important periodic tables for cards and for magic? Because there is one of the few cases where you have nature provides you natural numbers. Natural provides you 1 proton, 2 protons, 3 protons, and so on. That's crazy. And second, because there is one-to-one correspondence between atomic symbols, 1 or 2 letters, and atomic numbers. So you can take all kinds of classical games, like calendar and so on, and transform to periodic table. We have done that with Fernando Vasco, who's there, and have had some kind of success. You can do all kinds of things here. I carried out a classical Gardner game with numbers, but then we transformed it into just take 4 atomic symbols, please. Choose one, 4 people, 1 out of 2. look at their atomic numbers, sum them up. What's the number? Oh, lead. Great, we got it. So you can do all kinds of things. It's better explained in our paper in the exchange gift. So we think that the periodic table is very interesting for magic. Here is a nice example, because all atomic symbols may be 2 letters, they are not symmetric. And now I want you to explain, ask you something. Magic has come to chemistry. Chemistry is magic as well. But I would like you to ask, look at the badge, and how many symmetric 2-letter pairs can you find in the periodic table? How many of them are fully consonantic? And which vowel is dominant? This is kind of gamification of magic and the periodic table. Thank you very much.